Hello and welcome. I am Param Singh and thanks for joining today. Sometimes we want to model information that contains finite number of distinct items. These are often called enumerations, and Elixir provides a data type to model this type of information, and that data type is called atom. Let's look at a few examples of what that information would look like. So you have days of the week. So there are finite seven number of days in a week. So this can be modeled with an atom. Months of the year. So you have January all the way through December. So we have 12 number of distinct items. Characters on a keyboard. So there could be 130 or so characters on a keyboard. So again, there are finite number of possibilities, and thus this type of information can be represented in Elixir using atoms. Keywords in a language, we know that there are just a handful of keywords in any language. So this can be modeled with atoms as well. Genres in music. The other two examples are kind of more close to the Elixir language itself. For example, the Boolean data type in Elixir is modeled using the atoms. So it is not a special data type. In fact, once you have atoms, they have used that data type to represent true and false values, because again, you have two distinct items, true and false. We'll look at tuples real soon, which is a compound data type. Atoms is quite often used in the language itself to represent a part of that data in the tuple. For example, opening a file may return a tuple of a pair data, meaning two items, where the first item is a atom representing the state of the result. For example, OK or error, and then depending on that, you could use the second piece of the data there. So how do we write the atom? So you start with a colon followed by the name of the atom. For example, colon silver, colon high, colon red, colon country. These are all examples of atoms. So we have built a program earlier where we modeled traffic light to determine the next state of a traffic light given the current state. And at that time, we model the light as string, the state of the light. Now we want to convert that string data to atoms. Before we do that, I quickly want to show in IEX that the Boolean values true and false are in fact atoms. So true is a Boolean value in Elixir, and if I say double equal colon true, which is an atom, it says true. And similarly false, if I say double equal colon false, that is also true. This means that these two are equivalent values, and thus one can say that false is an atom. All right, so now let's go back to our function redesign, and we start with the usual first step to look at the signature. And instead of now taking a string as an input, we are going to say that it takes atom as an input. But since we also know that very specifically it's only going to take 3 kinds of atoms, so we can write that as it's going to take red, or which is represented by pipe character, colon green, or colon yellow. So this becomes the input, and if I change that as well on the output side, so there we have it. So this is the updated signature, that next state is going to take the following 3 atoms and one of those, and also it is going to produce one of the similar 3 atoms. So let's change this to green, and this as well, and let's change this to red, and let's change this to yellow, and finally to red. So our implementation simply changes the string values to atoms. The purpose statement remains the same: produce the next state of traffic light given the current state. Let's look at our test file real quickly, and for the sake of brevity, I have already updated the test file to use atoms instead of strings. So next state colon red should give me colon green, and so on and so forth. So let's jump to our terminal, and I'm going to run mix test, and I see that all my 3 tests pass. So there we have it, a function redesign that now uses atoms instead of strings, because our data type is an enumeration, which is fixed number of distinct items. One thing you might note here, that as the size of the data type, meaning the number of unique items, go up, it becomes cumbersome to write the signature of that function. So here I have 3 distinct items, and I had to write that in the signature. Imagine if you have to write the characters on a keyboard, so you might have to write 130 atoms each time in each function, and that becomes quite cumbersome to write. In the next video, we'll look at another feature of Elixir which helps us to alleviate some of that complexity by introducing your own custom types.